Good morning, students. Today, myself, Alok Kumar Mishra, is going to discuss about the main important topic of the physics, electric motor. You all know about the function of electric motor. How does it work? In we see generally this, like in electric fans, it is based on this electric motor. Computer CD, MP3, mixers, and any rotating device to which we are using nowadays are based on electric motor. Then, what is role of electric motor in domestic purposes as well as commercial purposes? We will discuss today. Students, it is a device which converts electrical energy into mechanical energy. Understand? The main conversion of energy by electric motor is from electric energy into mechanical energy. That means continuously electrical energy is converted into mechanical energy by the use of device. The name of that device is electric motor. It is of two types, AC motor and DC motor. Okay. Now, these are the devices which are based on that. Okay. Today we will discuss what will be its principle, what are important components, and how does it work, and how is it connected with electrical source, that is electricity. Understand? Because electric motor works, runs by the electric energy. By the electric energy. Before going through that, we need to draw the diagram of the electric motor. Understand? Now, okay. So just say it consists of various important components. There is a rectangular coil. I'm just going to draw a rectangular coil A B C D. A B C and D. Okay. Now after that, this rectangular coil is placed in a strong magnetic field. In is the poles of the magnets in a strong magnetic field, because it works on this principle. We will just discuss about that. And axle is connected, and axle is connected with split ring. First of all, we will see the split ring R1 and R2. I have just drawn, and this point is connected. This point is connected. The terminals, the end of the rectangular coil is connected with that. Understands? Now, the split ring is connected with two brushes. Brushes B1 and B2. Brushes B1 and B2. Okay, and these terminals are connected with source of electricity. Here I have drawn, says that means this is motor I have drawn here. Okay, and connected with switch. Okay, this is the electric circuit. This is the electric circuit. Now current is from A side. So before going to discuss, and this is the axle attached, this is the axle, so which direction it will rotate in clockwise, we will discuss. These are the important parts. So what happens now in this? The current comes down here. Okay, this is minus and this is the terminal plus terminal and this is the volt source of electricity. So it consists of, it works on the principle that a current carrying coil, a current carrying coil placed in magnetic field, placed in magnetic field experiences force, and the direction of the force produced in it is determined by the important rule, Fleming left hand rule. We will discuss this rule also regarding these apparatus devices. Understand? So come to that point. So what are these? Then the function is that electrical energy is converted into mechanical energy by the electric motor. Components. What are the components? It consists of various components, important parts, rectangular coils. You can show that armature. We will discuss about that. Armature is a rectangular coil made up of soft iron ore, ABC, on which insulated copper wire is wrapped in number of turns, which is placed in magnetic field magnet. So second is field magnet. Third, split ring. Third component is split ring. Split rings. It is in motor. It behaves as a commutator. So we will write now commutator. Okay. This is commutator. Where is commutator? See, commutator is a metallic device. Half of the rings, its shape is half of the ring, which is fixed in action, which is fixed in such a way that, which is arranged in such a way that axle that the terminals, the end of the rectangular coil is connected. The end of the rectangular coil, the function of commutator, that is split ring, is to reverse the direction of flow of current after at every half rotation of the rectangular coil. Armature here, rectangular coil A, B, C, D. Okay. Then after that, split ring is okay. Understand? Now brushes. Third part, fourth part is brushes. Brushes S1, B1 and B2 is written here. Here B1 and B2. Brushes are made up of carbon rod, and which are fixed in such a way that the axles attached with split ring rotates without rotating itself. The brushes are fixed and the terminals of the brushes are connected with the source, plus and minus. When the current passes through the coil A, B, C, D, rectangular coil, soft iron core, then force is developed. Force acting on its arm. This is the left arm AB and this is the right arm CD. Here we see it doesn't experiences force, only this, the point can experiences. So this is the brush. And the fifth part is the electric circuit. The fifth part is electric circuit, which provides source of electricity. When switch is in on position, when we switch on, then current passes through this. The current enters through the AB arc. The current enters through AB arc and through CB arc it leaks out. So first of all we will discuss at that point what you just see that. I'm just going to remove this to see clearly how it does work. Where is force acting on this arm? Here, the coil and the arm AB. Here, north pole of the magnet, the strong magnet. So, the direction is from north to south. B. Direction of strength of magnetic field. B is written. Now, direction of current is upward. Now, we will apply left hand rule. Fleming left hand rule will discuss after that. So Fleming left hand rule, just see that the forefinger is here along the direction of field, north to south field movement. Now and the middle finger through the direction of current. Then the thumb represents the direction of force acting on the current carrying conductor placed in the magnetic field. So here, just see that this is the B, this is the B, and just I am going to write here. This is the forefinger. So B. Now and this is the current and this is the middle finger. We will discuss again. So this is the flow of current. I am just going to write here. Okay. So this is current I AB and this is the B field. Just say mutually perpendicular to each other. Then the force is downward force. The force is downward. Now and here when it comes out, then the force is again here B downward force and here C upward force. Then a pair of force. When a conductor is placed in magnetic field perpendicularly, then it experiences from in left arm, on the left arm, the left arm AB pushes itself down and the right arm CD pushes it upward and a pair of forces act on this basic parts and rotates anti-clockwise. And if anything, blades, fans are attached here, then it rotates here anti-clockwise. Anti-clockwise, it rotates. Anti-clockwise, this is how it works. So, once again here, how students just see here the force, the direction of the force is determined by applying Fleming left hand rule. So first of all, after every half rotation, it changes its direction. That's why rectangular coil continuously rotates without breaking itself. बिना टूटे ये completely rotate करते रहता है constantly. Okay, because of a pair of force acts on that. That is torque. You will study in higher classes. So here, just see that. So force and what are the methods to increase the power of the motor? We can change the power strength of the motor by changing some factors, by removing some factors and inserting some factors on that. Okay, so the strength of electric motor, the strength of electric motor depends first number of turns of insulated copper wire. If number of turns increase, the power of rotation, the most rate of rotation increases. So first number of turns, number of turns in the armature, turns in the armature. Okay, it increases. Second, strength of the field, magnetic field. Strength of the magnetic field. Strength, that is B. The strength of the magnitude of the magnetic field. Magnitude of the magnetic field. Magnetic field. We can increase it by replacing permanent magnet, by replacing this permanent magnet with the help of electromagnet. So its power can be increased. So B can be increased. Hurt factor, area of the rectangular coil. Hurt factor is area of cross section. Area of cross section of the rectangular coil. Area of the rectangular coil. And the fourth is amount of flow of current. Amount of flow of current I. Flow of current I. These are the factors. If we change, these are the factors. If we change, then the power of the electric motor is changed. So this plays very important role in all spheres of life, in all parts of the science, okay, in physics especially. So that is based on the principle that a conductor which carries some current and placed in magnetic field, perpendicular. In perpendicular case, it will act maximum perpendicularly. The rectangular coil here A, B, C, D made up of soft iron core or material, then it carries, if current carrying conductor, then it experiences force. Then it experiences a pair of force. Right arm in upward direction and left arm downward direction. So this the force of direction is upward and that force of direction is downward. So downward direction. If supposing, just I am taking this example, pen, supposing this is the axis of rotation, and if that is in this direction, force acting in this direction, downward direction, and this one force is acting on, then it will move anti-clockwise, and electric terminals can be changed, the rotation can be changed. So that is actual blades are connected in that, and it starts. Now again, so what are the methods to use in commercial purpose? Commercial use, what are its commercial use? How can it be converted into commercial purpose? Okay, so it means in direct way we have to convert it in powerful manner. So how and in how many ways it can be converted? By replacing first permanent magnet with the help of electromagnet. If you place in between the rectangular coil, then the power of the electric motor increases. Then the power of electric motor increases. Next, if the number of coils turns, if the number of turns increases, and then power increases by replacing, by connecting the strong force, a strong source of electricity, then its power increases. Then its power increases. And what are the functions? Once again, armature is of iron core in the shape of rectangle, which is placed in field magnet. The function of field magnet, permanent magnet is used here to provide strength of the magnet. To provide students the strength of the magnet. This is not. This is. It may be horseshoe magnet or any other two bar magnets. You can keep and produce electric field. Second, split ring. Split ring is in the form of half of rings made up of metals. Made up of metal. From inside, it is insulated and fixed with coil. Axle. Fixed with axle. Coiling of the axles. And outer surface of the split ring is connected in such a way that with brushes B1 and B2 in such a way that the axle can rotate smoothly without rotating the brushes, and the terminals of the brushes are connected with the source of electricity. When electricity passes through this, a pair of forces on A, B, C, we find here acts on that, which tends the rectangular coil to move easily, either in anti-clockwise or in clockwise. Here, the fan rotates in anti-clockwise because here enters left arm, the current enters, and through the CDR, right arm it comes out, leaves the terminals. Now, this is the function. Okay, so what is Fleming left hand rule? Some boys are unable to understand that the direction of the force, in which direction actually it is acting on current carrying conductor if placed in magnetic field. So come to that point. So how is the direction of force? The direction of force acting on current carrying conductor in magnetic field is determined by that Fleming left hand rule. So come to that point, Fleming left hand rule. Now I'm just going to draw here. This is in, no doubt, Fleming, 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 Fleming's left hand rule is used to find the direction of force acting on the current carrying conductor. And in which direction the force acting, in that direction rotation takes place, motion occurs. So it gives the direction of motion of the current carrying conductor placed and magnetic field. So now, what is this statement? First of all, left hand rule. Just try to stretch forefinger, middle finger, and thumb. Here, my left hand, and that is given now. So that is given. So forefinger, that is in the direction of the magnetic field. This is the middle finger, direction of the current, and the thumb are stretched mutually perpendicular to each other. So I am just going to draw this forefinger, that is also known as index finger. Forefinger, index finger, this is the ring, and this is the middle finger. This is middle finger along which current flows. Current flows. Then the thumb. This is the force direction, motion. This is direction of motion. So thumb this is. thumb of left hand, thumb of left hand. Okay. So once again, a statement is that if forefinger, middle finger, and thumb are stretched mutually perpendicular to each other in such a way that the forefinger indicates the direction of magnetic field, and the middle finger indicates the direction of flow of current, then thumb of the left hand certainly indicates, then the thumb of the left hand certainly indicates the direction of the motion, that is the direction of the force exerted on the conductor. On this principle, rule, rectangle coil experiences the force and the direction of the force is determined. Okay, so here the principle is, you can write here all these two. A current carrying conductor placed in magnetic field, magnetic field experiences force, and the direction of the force acting on the conductor, current carrying conductor, is determined by the use of the Fleming left hand rule. Very important rule. So Fleming rule is very important. So we can write here and try to understand that same thing, same concept is acting here to produce. Understand? How can you remember? To remember Fleming's rule is very simple. So here I'm just writing that part, Fleming left and rules part. Okay, here just see, or forefinger. First of all, you write left hand. Okay, left hand, forefinger. B, forefinger. B, okay, is direction of magnetic field. Magnetic field, strength of the magnetic field. Second part, middle finger. Which finger? Middle finger. Middle finger indicates the direction of flow of current. Then third part is, here you have to write thumb. Thumb, you have to write thumb, and thumb is direction of force. We can so write here motion. We can write the motion. This first part, second part, and third is final conclusion. Here, with the help of these two mutually perpendicular finger, forefinger and middle finger and thumb are stretched mutually perpendicular to each other. Thumb certainly represents the motion. Certainly represents the direction of motion acting on the current carrying conductor. Acting on the current carrying conductor. Okay. So this is a very important part, and this is, so students, don't forget to write left hand. It is left hand rule. Right hand rule is different. That was also deduced by Fleming, and that will be applied in generator and electromagnetic induction in generator. So electric motor works under this action, under this principle, and it is very useful in our daily life, practical purposes, or in industries. So, what are these? You know that what is its function, what is its principle, what is its working principle, and how does it works. It's very important for exams also. So, today, thank you, boys. Thank you, and work hard home, stay at home safely, and study. Thank you. Thank you.
क्या बात है